Or maybe I will maybe give you example from the early beginning of the series. Okay, try this first. So you have this series of the first one is 2 plus n over 1 minus 2n, and the second one is e to the n over n squared. Okay, since this is the early problems, the simplest method that you can do to determine whether the series is converged or diverged is just using the divergence test. Divergence test. Yeah. Okay, so for the number one, using divergence test means if you see any an, what you need to do is you need to limit, and we need to solve the limit of the sequence. Okay. So limit, we solve the sequence, and from this limit problem, we can conclude that the solution is negative half, right? It's not a complex problem. What you need to do is just using limit, okay? Uh, try to determine this sequence from the series, okay? And when you find that it's not zero, you can go conclude that, okay, this diverge. Yeah. Okay. I hope it's easy to understand. So conclusion, uh, the series is diverge. So whenever you find any series, the first thing you can do is actually limit the sequence. Okay. But also it depends on the questions. Okay. If the question is asking how much the value, if it is converged, then you need to find the value. But if it is just asking whether it's converged or diverged, you can try any method actually, any method. For number 2, we can limit this to e to the n and over n squared. Same way, we remember, okay, this is infinity, right? So we can use L'Hopital rule. So we can write down e to the n is still e to the n, and this is 2n. And still, we can one more time L'Hopital rule. Now, the second one is actually going to infinite, right? Or this is, again, it's not 0. So it's the same as the first one. The series, okay, series of this is also diverge. So whenever you find the sequence, the limit of the sequence is not 0, that means it's diverged. Okay? Unless you find it's 0, then it's converged. But then maybe the question is asking how much it will be converged. Then it's asking the value. So you need to have a different approach. Okay. So that's the first one. The second one, still the same questions. Determine the series converge or diverge. Okay, 2 questions. After we've done this, I think we can go to 11.5. And this is also to review what you have learned from calculus 1. It's asking how about, let me just specify to narrow the questions. Determine the series using integral test. Okay, using integral test. So in this case, I want to explain these 2 questions with the uh, integral test method. And first thing you need to observe if you want to use the integral test. So integral test, the function should be continuous function. positive terms, and then the last one, the important one, is always decreasing. Decreasing, especially at the value that mentioned in the series. Like for example, number 1 is from 1 to infinity, number 2 is from 2 to infinity. So you need to make sure that the function will be decreased from the first terms. Okay. Or I'm going to write here, decreasing from the first term. Okay, first for number 1, let me write the questions. It's k and then k e minus k. Okay, consider or maybe I will write like this. Okay, to prove or to make sure that it is decreasing, we can use the calculus 1. We find the first derivative. And then it will be e to the x minus x e to the x. And we can divide all by e to the x. So 1 minus x over e to the x. And to be decreasing, it should be less than 0. Okay, so decreasing. So decreasing when x is greater than 1, right? So it will be decreasing when x greater than 1. Okay. You try to plug in 1, it's the 0, right? And if you increase x, it will be negative, right? It will be decreasing. It will be, or if you want to have a complete answer, okay? So it should be decreasing, okay? The value will be decreasing. And then after we prove this, we can use the integrations from 1 to infinite. Let's just use x. Or we can use the t for the solution. Okay. Now, can you still remember how to integrate this? Or this? X multiplied by e with the power of negative x. Do you still remember? If you cannot figure this out, you will be in trouble. But anyway, let me give you my preferable solution. Maybe it can help you. You can use by default integration by parts, udv, uv minus vdu, blah blah blah, right? You just need to find out which one is u, which one is dv. But my preferable solutions is separate between this x and e to the minus x. This one I call b, this one I call I. Okay. The one with D, I need to differentiate until 0. The one with I need to integrate. Okay, we go here and we go here. Okay, integrate. Okay, and then add plus minus plus. Okay, the proof of this method I already showed you the last semester. So it's actually integral by parts. Okay, integration by parts, but in a good way to present. Okay, and then multiply this. Okay, and then that is our solution for the integration. Okay, I hope you get the idea. So the solutions will be, let me write limit d. This is negative x and then minus e minus x, and then plug in the 1 to t. Okay, and then solve this. Plug in t. Okay, now this will be 0. Okay, and this will be solved by the L'Hopital rule. So it will be negative 1, and this also be 0. So the solution will be, oh wait, it should be plus 2 over e. So this converges by integral test. Okay, any questions from here? Okay, I hope you get similar questions having integral, and then you need to, you know that it can be solved by integration by parts. This method actually can be faster. Okay, but it's up to you. If you want to use the by parts the traditional way, that's also fine. It's also already fast. Okay. Okay, number the second one, this one. Okay, if you want to prove that this is decreasing, you can do the same thing. Derive, and then the first derivative should be less than 0, and you get the what x should be for decreasing, and you can prove that. And then later, same thing, you can go from 2 to infinity, and x squared dx. Okay. Or here, let me go by. Okay. Now to solve this, we still need the integration by parts. But here, because ln x, we prefer to be derived, right? Rather than integrate, because if you want to integrate, you need another by parts, right? So we write ln x and then x to the power of -2. This is di. And same thing. Okay, let me just stop here. And this should be multiply. Okay. This one is also, you need to multiply the 0 to here, but it's 0, so you can ignore that. But here, if you have the derivative part is not 0, so you need to multiply this. Okay. So plus ln x, negative, you multiply, and then minus this part. Okay. So we can write, or let me just write the solution, minus x, oh wait, minus ln x over x, and then 1 to, not 1, from 2 to t, and then plus integration from 1 over x squared. Okay, and I think this is not too complicated, supposedly. And then plus, this become 1, negative 1 over x with t and 2. Let's solve this first. Okay. So by the end, you get, oh, let me write this is, you can solve this by L'Hopital rule. You get the, right? And this becomes 0. This becomes 0. So the solution will be ln2 plus 1 over 2. So it's converged. Okay, can you follow all the methods? Okay. Okay, my suggestion, if you cannot follow in this class, you can try later after class. Try by yourself. Make sure you can do all this integration. If not, then I cannot help you in any way. Sorry. Okay. So that's just reviewing some parts in 11.2 and 3. Okay. And I have checked all the score this class. So maybe at 240, maybe 240, I will deliver to you. Okay. Now we can move on to 11.5. Okay. It's called the alternating series. So whenever you find any series that has a +1, negative, and then plus, and then negative, and then plus, and then negative, this is called the alternating series. And first, before we are doing the converge and diverge test, we need to define the pattern, the formula first. Okay, so it starts from +1, and then negative, and then positive. Every time you see negative, positive, it should be having this -1 with the power something. Okay. Now, the first term here, second term, third term. The first term is positive, right? So of course, the one and here should make the negative become positive. Okay. It can be 2. It can be what? It can be n-1. It can be also, because it will be with the power of 0. It's 1, right? But let me follow this n-1. Okay. Because here it's 2 minus 1. It's negative. It's correct. And 3 minus 1 is 2. It's positive, etc., etc. Actually, you can in any way you prefer, as long as it's correct. That's okay. Okay. But I need just to follow the textbook. Okay. And then the other part will be the value. Okay. It's just 1 over n. Okay. And then maybe the other one it starts from -1 over 2 plus 2 over 3, and then minus 3 over 4, and then plus 4 over 5, and then minus 5 over 6. Okay. Same way, we are separating the -1, and because it's starting with the negative, we can just say it's just n. Okay. It's from 1, 2, 3. Okay. So we can just write down n here, and then the formula for the sequence or the series here, it's just n, and then just this part, the bottom one is just n plus 1, right? Okay. Okay. So what's the important thing here is in alternating series, it's actually similar with the other series. The difference is just this negative part that makes the alternate sign. Okay. So we can write down the an is either this or depends on which terms at the beginning having positive or negative. And we can also say that Pn is actually the absolute value of the n itself. Okay. Let me write the theorem for the alternating series. So right, this is maybe from B1 minus B2 plus B3 minus B4. And Bn is greater than 0. This should be satisfied number 1. So the next term should be less than the previous terms. Number 2. Okay. So remember this? It's actually the divergence test. Okay. So it will be included in most sections in the chapter 11. They need to include this part because this is the way that proven to be convergent. Okay. So if the series satisfies these two, then series is convergent. There are some proving in your textbook, but the proof, because using the limit equals 0, then the value will be the same. And you can check in your textbook, but I will not tell you this hour. But probably let me give you the visuals, at least the visuals. Why it's true that it's converges. Okay. I start from 0, and then let's say this is S1. Okay. Okay. Let's say this is the P1, this line from here. Okay. P1. And then from here until here, it's minus B2. Okay. Let's say this is the S2. And then from here, because the next terms is always less than the previous terms, it will always here, maybe less than here. So it will be going to 1 point. Okay, it will going to be like closer to 1 point, maybe here or here. Okay, from the picture. So let's say this is plus B3 or B3, and this is S3, and then going backwards, maybe here, and maybe this minus B4. This is S4, and then similarly, it's going forward less than B4, but This is the S5. This is B5. Okay. You'll see from 0 plus B1 minus B2 plus B3 minus B4 plus B5, and then maybe minus B6, and then maybe around here. Okay. So whenever you see any alternating series, the next term is less than the uh, previous one, and then you know that the absolute value of the sequence, you limit them, it's 0. If both are correct or satisfied, then the alternating series becomes converged. Okay. Okay, let's maybe write some example. If you want to write the formula, this would be 1. Okay. First, if we look at the bn plus 1 less than bn, if you look at twice, maybe from 4. 1 over 4 less than 1 over 3 is less than 1 half. It's less than 1. So it's correct, right? So satisfy this. And number 2, we limit the sequence, the absolute value of the alternating series, and it's 0. Okay. So conclusions, the series converges. Okay. It's not too complicated as long as you can prove that the next term is less than the previous. Okay. And another example. Series from 1 to infinity. Okay. What about this one? Okay. You have alternating series with the negative 1 to the power of n and 3n over 4n minus 1. Okay. Remember, the simplest method, the early method that you have is divergence test. Just use that. We limit this, right? And because it's 3 over 4, it's not 0, we just can conclude that this diverges. Okay. So whenever you find the series, uh, you can just always using the divergence test. Okay. And it's also included in this alternating series. You need to check the divergence test. So because limit because this is 3 over 4 and it's not equal 0, so series is divergence. In this part, the alternating series also have the estimating sum like the integral test, but I think the way uh, the way it applies is similar. So I think I will skipping that and go for the absolute convergence and conditional convergence. And maybe we can review some questions next Thursday. Okay, so I will give you the method and then we review with the exercise next Thursday. So right here, absolute convergence and conditional convergence. Okay, let me write, given any series, any series an, if we have this, then it will be this. So by definition, uh, series is called absolutely convergent if the series of absolute values sigma is convergent. Okay, that's the absolute one. And there is other one, it's conditional convergent. So it can be convergent, but it can also be divergent. Okay, depends on the absolute. Okay, so another definition: series an is called conditionally convergent if it is convergent but not absolutely convergent. Seems a lot of words, but it's actually practically easy to understand. So meaning, if an converge, the absolute value of an diverges. Okay, this is we call the status for the converge if just this an. If this is converged, but then if we look at the absolute value and it turns out it diverges, then we call this phenomena or this case, this problem is conditionally convergent. Okay, so it may converge, but if we look at the absolute value, it will be divergent. Okay, just definitions. Just definitions. Then the theorem. Uh, if a series absolutely convergent, then it is convergent. Okay, to help you understand the conditionally convergent, um, if you look at the alternating series, the harmonic series, 1, negative 2, half. Okay. If we look at the absolute value, this will be 1 plus half plus, which is we can also say that from the P series, okay, because it's 1 over n, P, right? And P is equal 1 here. So the series diverge, right? But if we look at the alternating series is converged. So these situations, okay, the series converge, but its absolute value is diverged, then we say this is actually conditionally convergent. Okay. Okay, let me give you another example to see how it works. Example. Determine the series absolutely convergent, conditionally convergent, and divergent. Number A, Okay, the first one is actually we already see this form before, right? The similar way. We're just using the divergence test, testing the sequence. It's half, so it's not equal 0, which means we can conclude that this series is divergent. The second one, if we look at the absolute value, it will be this, which means if we look at the P series, P is less than 1, which means it's diverge. But by alternating series, let me write. But its alternating series is converged. Because we know that the Bn plus 1 is less than Bn. Right? So this is called the conditional convergence. The last one, the absolute value is given by this formula. P is greater than 1, so it's converged. And by alternating series, it's also converged. So this case is uh, absolutely convergent. Okay. So to determine the absolutely convergent and conditional convergent, you need to just put the absolute value and check whether the series is become converged or diverged. Okay. And you have, if you have the contradictions, then it's conditionally convergent. Okay. And if both converge, then it's absolutely convergent. Okay. Any questions? Actually, the next method is one of the fastest way to look or determine the converge or diverge. It's called the ratio and root test. So let me just make some introduction for ratio and root test, and then I will go for your quiz results. So 11.6, a ratio and root test. So ratio is actually from the terms is comes from the geo series. Okay, this R. So the geo series say that the R should be less than 1, so the series can be convergent, right? So we need to manipulate our sequence or our series to find out whether they are less than 1 or not. Okay. So ratio test. Let me just write the test. Okay. Uh, if uh, if limit. Yeah, let me write all of them first. If you have the ratio and then it's equal some value, and if the value is less than 1, then series of that an is absolutely convergent. And then the second one, if limit if this is greater than 1, similar in the geo series, if that greater 1, then it's diverge. Okay? Divergent. And if limit but then if you have equal 1, what will happen? Now this is the ratio test is inconclusive. No conclusion, which means we need to move to other method if this happens. Okay, I will give you one example, or maybe two. Test the series. Okay, if we use the ratio test, we check the value for an plus 1 over an. Okay, we check this. And then we can solve. And then we can also solve this. So limit this part is 0, so we get it's 1/3. It's less than 1, so we can say that it's absolutely convergent. Okay, aside from divergence test, this one I think pretty useful because it's pretty fast. Okay. Any questions? So let me just stop here for now and let me give you the results. And then maybe get 1 or 2 students from each department. Okay, from global, maybe 2. From ITP, maybe 1. And maybe from the CE, maybe, oh, maybe have ITP. Yes, ITP here. Okay. Oh, it's the second one. The yeah. Here, GDP. Also GDP. Here. Uh, yeah, you can check from here. Mm, Have you checked here? Let's wait. And actually, there is. Okay. Okay. Have you checked this from Rohit? Can you check your name and your classmate? Okay, please check your score. Really? Wait, wait, wait. No, it's E. No, it's not. What's your number? Yeah, I've checked number. Wait, wait. Yeah. Oh, okay, 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 okay. Yes.
This part, I think the graph is from there to there.
Mm.
So I rolled 5 times
Yeah,
and go back.
but you're wrong here. It's
So I have to write a big.
no, 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 no. This is two different integrations.
Oh,
Yeah.
so it's not like this.
No.
Oh,
Yes.
little thing. If I integrate from power 6 to
Mhm.
power 2, is it just
Yeah.
like
Just
the half of the leaf?
yes, yes.
It's not until down, right?
Mm.
It's not like partition that it's
Mm.
all the way
Mm.
down. It's not. I want to calculate this triangle, but I don't know why can I use this method,
Mhm.
and I only get 2 points. I don't know because 1/2 big
Mm.
sine theta.
Mm. Yeah, I think um, this is.
And the result
Mhm.
is since I use integral. Because when we test, I calculate this
Yeah, yeah.
quantity many times.
The idea is correct. You find this, and then you minus this to here, right?
I I
A1 minus A2, right?
yeah.
Yeah, that's correct. But I think uh, this part I don't know why you calculate this.
Oh, I calculate is wrong because it is
Yeah.
minus. So
But what I mean is this part,
part
it
is
should be the 3 cos theta, right?
I separate the graph in two parts.
Mm.
So I use A1 minus A2.
Yeah, the idea is correct. But I think something missing in here.
But A2 I use integral
Mhm.
and the result answer is same as
Yeah, I confused this part.
oh it's over there
Yeah.
because this is not.
Mm. Yeah, I mean, if you calculate, I think it should be 5/8.
Right.
Yeah. How many point here? Huh? How many you get? Right. Yeah, I can give you at least 3 more points. Okay. Okay. Let me.
So this is
Yeah.
wrong.
Yeah. Your ID is 106. I already marked your
Answer.
yes. Let me check. Number 4, right? Oh yes, this one. This is yeah. Okay. Let me check the other one. Okay. I can give you at least the same. Okay. Okay. Let me just write your name and I'll add. Okay. Okay. Finish? No need, no need. Which one? Which one?
I think we joined the same answer.
Oh yeah. Right. Oh yeah. Let me check. This should be. Let me take notes. So this I will add 3.
And
Okay.
and
And
and this
which one?
before test didn't you say that only do the integration part, but I just have some
Yeah.
mistakes in here.
Wait. Is this correct? It's correct, right?
Yeah, the same as this.
Oh yeah. Sorry. Oh, 90. Okay.
Okay.
Okay, this 5 more minutes. Okay, 5 more minutes. Okay. Or if you want to collect, you can collect. Okay.
Number two,
Mhm.
is it possible to simplify it more?
Yeah, it's possible. It's possible. Uh, I didn't bring. Yeah, it's different class. Yeah, yeah.
Cannot do it anymore.
Really? Okay, okay.
I see your first question. The first question.
Yeah, I think. Yeah, I know.
The
Wait,
question.
wait a minute. Let me think here. Okay. Yeah, yeah. Let me check. Here.
Oh, I forgot the physics.
Yeah, you switch. Yeah, yeah, yeah.
Oh, there's a mistake on the
Yeah,
derivative.
yeah, yeah. But let me check. The first one should be 18, but I think I can give you more because you didn't take any mistake aside from here, right?
Yeah.
So at least I can add 4. Okay.
Yeah. Okay.
Okay.
Thank you. Teacher, may I take a look for the next semester finals?
Yeah.
Well, I'm quite curious. That's
I.
the original score.
Oh. Okay. Okay. Um. Maybe later I will give you the list, your
Okay.
score. Okay. Okay.